Cortana. We are honored to have with us respected Shri we are honored to have with us respected Shri S.R. Narsimhan, Chairman and Managing Director, Grid India, and Chairman, SIGRE National Study Committee C2 on Power System Operation and Control as our chief guest on the occasion. We are very grateful to you, sir, for your valuable time and gracious presence on the occasion. Thank you so much. We are also honored to have with us respected Shri R.K. Purvalji, Director, System Operation, Grid India, and Shri Hemant Jain, Chief Engineer, CE.
This webinar series was conceptualized to discuss the effects of high penetration of variable renewable energy in the Indian grid. First 2 days, that is 1st and 9th of December 2023, were conducted through virtual mode, and we received a great participation in the event. Approximately 1,000 participants registered for the event. Today, the third day is being conducted through hybrid mode. I am happy that we have with us Shri S.R. Narasimhan, CMD Grid India, Shri R.K. Porwal, Director System Operation Grid India, and Shri Hemant Jainji, Chief Engineer CEA, to grace this occasion. Welcome you, sir. I also welcome all distinguished experts who have joined us and delegates coming all the way to participate in this program. In present competitive and challenging era, updating the knowledge in respective field is the most essential thing which helps improving the skill of individual, organization, and the country as a whole. CBIP is organizing knowledge sharing session on the important topics on regular basis. CBIP is trying to contribute to maximum for helping professionals in increasing their knowledge. CBIP has also ventured in new areas like technical audit of thermal, hydro projects, and substations. I am confident that the participant will take maximum advantage of eminent experts available for deliberation on the topic. I hope the webinar series will provide an opportunity for free and frank interaction and discussions on the problems, strategies, and technologies related to the subject. I wish that the webinar series result in a useful inputs to achieve its objective. I once again welcome you. Thank you. Thank you very much.
Thank you very much, sir, for your kind address. We also thank you for your guidance and support to CBIP team for organizing this important webinar. Thank you very much. May I now invite Shri R.K. Porwal, sir, Director System Operation Grid India, to kindly say a few words about the issue.
Thank you. Thank you very much. Respected Sri S.R. Narasimhan, CMD Grid India, Sri Hemant Jainji, my senior, college senior, as well as Chief Engineer CA, Sri Dinkarji, Secretary CBIP, and Sri Sanjeev Singh sir, who was in Power Grid when I was in Power Grid. He was Executive Director Power Grid. Thank you for inviting me for this very important webinar, or say physical as well as online webinar. This is really a challenge today when we talk about sustainability, because everybody is talking about sustainability and we have to make our system sustainable. And in this era, therefore, we are moving from fossil fuel based power system towards the more greener renewable energy power system. In this area, we all have to see that we have a great target. All over the world, we are transitioning from this economy to other economy. Therefore, this new entrant to our grid, we have been very knowledgeable about our conventional generation, their issues. So these new type of inverter-based resources which have come to our grid, we are learning about them. And there are certain challenges in integrating them. One challenge is that, okay, they are variable in nature, intermittent in nature. So therefore, we need to have some other resources which are flexible in nature, which have a high ramp capability, as well as how much reserves we do have in the system to mitigate those challenges. Another challenge from the more technical side is that they are controller-based resources. They are very fast controllers. So how they behave during different conditions in the grid, whether it is transient, steady state. So how will they behave under different conditions? That is another great challenge to be mitigated. Further to that, again, there are other challenges as well, say that they do not contribute that much to the short circuit level. They do not contribute towards inertia of the system. So these are the further other challenges. But as far as what we have learned about integrating so much of renewable in our grid, what we have learned that there have been several instances wherein we lost a great amount of renewable energy, and that can have a very significant impact on the grid reliability, grid security. So therefore, we all need to learn from those. We have compiled some of these learnings in our report, which is available on the website, our website, as well as the website of, as well as a link is available on the other social media also. So we will request that each and everyone should go through this report, very important, comprehensive report, I should say, and can give us feedback so that we can further improve on, and everybody improves on. So we have basically, again, experts from the Grid India have been giving the details about this report in different series, as Dinkar Saab has mentioned that this is the third webinar in this series. We have already done 2 webinars wherein a lot of questions, a lot of people participated in those webinars, and a lot of questions were there on this because this is a very important topic. So therefore, I will again request all of you to be live to these discussions. And today also, some of us from Grid India will be explaining the different facets of this report. And I feel that this is going to be a very learning experience for all of us. All of us will get more and more knowledgeable towards the challenges being faced by these inverter-based resources and how to mitigate them. And we are more knowledgeable about the resources available, about the solutions available to improve the reliability on the sustainability of our grid, which is the paramount importance, which is the target of all of us. So I am very sure that this webinar series will be helpful, and I wish very all the best for this webinar. Thank you very much.
Thank you very much, sir, for your very inspiring address. Ladies and gentlemen, it's an honor and privilege to invite Shri S.R. Narasimhan, sir, CMD Grid India and Chairman SIGRE National Study Committee C2 for his address.
Good afternoon, distinguished dignitaries on the dais, off the dais, and all those who are connected online. It's a pleasure, really a pleasure for me to welcome you all to this third webinar in this series of 3 webinars that have been organized by Grid India CBIP under the auspices of SIGRE National Study Committee C2. In fact, we saw a lot of interest in the earlier 2 editions also. There were a lot of interesting questions, and definitely it's all, we are all on the learning curve, and whatever has been shared, I would say this is only just the beginning. You know, we would get to see more and more of new devices getting connected to the grid, be it hydrogen electrolyzers, be it large data centers, and different types of bulk loads that would get connected to the electricity grid, and all towards the ultimate objective of sustainability, which Mr. Porwal just mentioned. Now, coming to, of course, sustainability is something which everybody talks about. In fact, the full COPs meetings, entirely all the discussion structure around sustainability. But the other important aspect of reliability, that also we must keep in mind, you know, and I always say that, you know, one realizes the value of reliability of electricity only when you don't have, you know, and that's the time when a lot of questions are asked on whether we had the required foresight while planning and operating the system. In fact, this is not new. In fact, ever since a lot of solar started getting integrated in the system, if we look at Germany, the amount of rooftop which they added in 2010 to 12, this was phenomenal. You know, not that Germany has a very good solar irradiance, but still they went ahead and invested a lot in rooftop solar. And starting from there, you know, when you talk about standards and their compliance, the 50.2 hertz problem was the first thing that was flagged almost a decade back, because suddenly you found that as the frequency crossed 50.2 hertz, the rooftop solar went out of the system. It was as a protection of the rooftop solar, but then that's fine. If you have only a few megawatts of rooftop solar, it doesn't really matter. But we could end up losing much more than the single largest contingency for the entire continental Europe. So that was the first time this aspect of the standard was flagged and the standards revised. In fact, Germany even went for a huge program of retrofitting of all the rooftop solar just to ensure that they are able to comply with the revised standard. And it's coming thereafter in 2019. In 16, of course, we all know about the September 2016 blackout in South Australia, where a lot of the wind turbines, they went out due to a fault in the transmission system, leading to overloading of the interconnectors feeding South Australia, and we lost the interconnectors, leading to a collapse of the South Australian system. So then questions began to be asked about LVRT. Do we need more stringent definitions on that and all that, And so that was one aspect. And then in 2019, 9th August 2019, we also had a situation of some interruption in supply in the UK system, when again, it was traced to a fault in the transmission system, and offshore wind facility, a gas turbine facility, they all went out, and it was much more than the single largest contingency. So again, there's the report of Ofgem and National Grid that's available in the public domain. And very recently, on 15th August 2023, we had a blackout in the northeast part of Brazil, and there again, the behavior of the reactive power capability by the RE generators and the behavior of distance relays, all that was analyzed, and the point is, in all this, there is always a tendency that you blame the RE, wind and solar, that has caused the tripping. But it's not really that, we have to actually understand the phenomena fully and take mitigating actions well in advance, and that's the entire purpose of this series of webinars which we have been holding. The idea is that we try to understand this fully, and take all the required actions so that we are able to add more and more wind and solar into the system. That's the purpose of this webinar series. And I'm sure you would have a very interesting set of speakers over the next 1.5 hours. So I once again welcome you all to this webinar. Thank you so much.
Thank you so very much, sir, for enlightening and enriching address. Ladies and gentlemen, let's start the session now. We have one presentation, that is a Grid India report on events in transmission grid connected solar and wind power plants by Shri Rahul Shukla and Shri Priyam Jain from NLDC Grid India. Shri Rahul Shukla is the Chief Manager System Operation National Load Dispatch Center Grid India. He has done his Bachelor of Engineering in Electrical Engineering from Rajkot Butler Technical University, Kanpur in 2008. He is having total 13 years of work experience in the power system. His work areas are real-time operations, post-dispatch analysis, and reliability. And our second speaker, Mr. Priyam Jain. He is a System Operation NRLDC Grid India. He is a Senior Member IEEE and PES. He has done his BTech in Electrical Engineering from IIT Indore. He is having more than 10 years of professional experience in this sector. Ladies and gentlemen, let's please invite our both eminent speakers on the dais, please. I request all of you to please welcome them with a huge round of applause. And may I now request Rahul sir to kindly start with the presentation.
A very good afternoon to all the esteemed dignitaries as well as all the members who have joined physically and online. So this is the third webinar of the series. The first one was on 1st of December, where we explained the RE connectivity process in the Indian power system, including the compliance verification part and technical data submission part. The second webinar was held on 9th of December, where the analysis of the events carried out using the measurement data as well as simulations was explained in detail. And this is the third and last webinar where we will provide a brief overview of the report that has been published by Grid India. So yeah, it would be difficult to cover all the important aspects of the report in 1.5 hours, but we have tried to cover all all the major aspects that can be covered in this short duration. So starting with the outline of today's presentation. So we would be covering all the chapters. We would be providing an overview of all the major chapters of the report, especially focusing on the measurement and simulation part, as well as the suggestions and recommendations. So starting with the size of the Indian power system. So as of now, we have an installed capacity of around 425 gigawatts against the peak demand of 240 gigawatts, which was met recently 2-3 months back. And we have around 180 gigawatts of renewables in our grid, including large hydro generation. And if you talk about the variable renewable sources, the capacity stands at around 117 gigawatts. So what has been the journey of renewables in the Indian power system? So starting from 2014-15, where the capacity was only 25 gigawatts, we have now reached 117 gigawatts of wind and solar capacity. On an annual basis, there has been growth of more than 19% since 2014-15 in the RE capacity addition space. In terms of the contribution of RE in the total energy requirement of the country, we have an annual contribution of around 11% coming from the variable renewable sources. And the maximum instantaneous penetration has been around 33%, which was recorded in the month of July this year. For some of the states, we can see, especially in case of Karnataka, the maximum penetration has even crossed 100%. During the last year. So what is the transition? What does the energy transition for the Indian power system look like in 2030? We all talk about the 500 gigawatt non-fossil fuel target in 2030. And most of this 500 gigawatt capacity would come from wind and solar generation. So we all have heard about these numbers, but along with indicating our commitment towards a greener future, these numbers also reflect the responsibility that we have towards ensuring towards facilitating the reliable integration of these sources in our grid. So these numbers do not just reflect the transition towards a greener future, but they also in a way underscore the responsibility that we have to kind of reliably integrate them in our grid. So coming with the challenges, we all talk about the challenges that come with the RE integration. We all have heard about the lack of frequency support that we will face with the displacement of conventional generation sources. We have heard about the voltage, the issues in case of voltage support, and regarding fault right-through failures, the reduction in damping, the reduction in line loadings, bidirectional flows, and all. But what we kind of underestimate is the impact of these challenges in the on the power system as a whole. So a simple right-through failure. So India is unique in the sense that we have large capacity of renewables getting connected to single pooling stations, and then we have multiple pooling stations in close vicinity also. So a simple right-through failure in a pooling station, or because of reduction in damping because of displacement of synchronous machines in the vicinity, we might end up with a large disturbance. So we usually talk about these challenges, but what is the impact of these issues, the challenges in our grid? We usually underestimate them. So how to tackle these challenges? So there is a simple 3-step way to, kind of address these challenges. First is specifying the technical requirements that we expect from the RE generation. Other is the adherence of these requirements by the RE plants. The next one is the periodic monitoring and compliance verification that the RE plants are actually complying with all these requirements. So if we have the solution with us, then what is the problem in large scale RE integration of RE? So why are these events taking place? So if we look into, if we go deeper into the numbers, then we learn about the challenges that come with large scale addition of RE. So out of 22 gigawatts of RE connected at interstate level, for the 22 gigawatt RE at ISTS level, we have around 50,000 numbers of inverters and WTGs on our grid. Now, if we try to, if we try to find out how many units would have been there if this 22 gigawatt would have come from the conventional sources, so number would come around 40 to 45. But with these numbers, the complexity increases multifold. We have complexity in the implementation of any settings. We have complexity in terms of unit-wise modeling, in terms of post-event analysis, in terms of ensuring compliance at each IBR level. So the complexity with RE increases multifold with all these numbers these numbers signify. So now why the requirement of publishing this report has come. So why have we published this report? So as you all know, there have been around 31 events involving RE generation loss of 1,000 megawatt or above starting from January 22 to May 23. So the main question was, why are these events taking place? Behind the scenes, a lot of analysis was being carried out by different RLDCs and NLDCs based on the measurement data that is available with us. A lot of simulations were also being carried out to kind of supplement the analysis carried out through this data. So we thought it would be pertinent to kind of compile all these findings, all these analysis, and publish them in the form of a report along with the recommendations for the benefit of the sector as a whole. So this is why whatever findings, whatever learnings were there based on the analysis of the events, we have published them in the form of a report. So coming directly to the report, the contents of the report are classified under 6 chapters. In the first chapter, we have tried to capture the intra-state and ISTS RE capacity on all India and regional basis. In the second chapter, we have explained the RE integration process in India in detail. So starting from the, when the developers approach the CTO or STUs for grant of connectivity, so the requirements of the technical data submission, why this data is required, what is the compliance verification process, how the compliance verification should be carried out, what is the requirement of the test reports, the certificates, the unit level and detailed simulation models, and what are the challenges that we face during the compliance verification process. All these have been covered in chapter 2. In chapter 3, we have provided an overview of the RE events that have taken place from January 22 to May 23. Out of these 31 events, we have also provided detailed analysis of 4 events. So we have classified these events under different categories. So one event falling under each category has been explained in detail in chapter 3. And then the limitations that we faced while analyzing these events have those limitations are also covered in this chapter. In chapter 4, the findings of chapter 3 through the analysis based on the measurement data have been supplemented through detailed simulation studies, and these simulation studies have provided very deep insights into the behaviors of IBRs as well as the behavior of the plant as a whole, and what actually has went wrong. Has gone wrong in real time. So we have definitely gained very unique insights through these studies. Now, along with all this analysis, we have also in parallel carried out a survey of the international practices in this area, and what we have a very robust set of regulations and standards covering the RE RE generation. These regulations broadly cover all the major requirements that should be there for in case of RE. But as we all know, this is an evolving field, and there are various technological advancements that are taking place on a daily basis in this area. So it also becomes important that our standards and regulations, we also try to update them on a regular basis, and we try to timely incorporate all the new additions that might be required for reliable operation of the grid in future. So all the learnings that we had through the survey of international practices that we have tried to cover in this chapter, and the scope of improvements in our regulations, wherever we found that there is a little scope of improvement, we have also tried to highlight that. And then all the findings and recommendations based on the survey of international practices, the analysis based on measurement data, the analysis based on the simulation studies, all that we have covered in chapter 6. And we have provided various recommendations based equipment design, the recommendations for equipment design, the recommendations for RE developers, the recommendations at regulatory level. We have provided these recommendations in chapter 6. So this is how the installed capacity has increased over the last few years in the ISTS system. So we can see that from almost negligible capacity in 2019, we have around 22 gigawatt of ISTS connected RE as on March 23. So here I would like to highlight two important aspects. So one is with capacity addition of RE, the number of events in these RE pockets have also increased. So it is with now 22 gigawatts of RE, we have almost had 31 large generation loss events. Another thing that I would like to highlight is that we also have 85 gigawatts of RE connected at intrastate level. So we can say that why these events have not taken place at intrastate level. So as I mentioned earlier, we have at the ISTS level, we have these large RE pockets. There are a lot of RE generation is coming at a single pooling station. And then these pooling stations are also in close vicinity. So the impact is also large. Whereas in the intrastate system, a large quantum of RE is not coming in a single location, and all these pooling stations are also dispersed in a large geographical area. So, and then there is also issues with the visibility of this data. So, yeah. And another aspect is if we see the capacity addition at interstate and intrastate level. In case of northern region, we have the RE capacity addition, skewed RE capacity addition in a single state that is mainly because of the higher potential. But here also, we should also keep in view the resiliency aspect, that we should not be, we should not enter into a scenario where a large chunk of RE generation is connected in a close vicinity and a single fault may lead to a large disturbance. So these are a few aspects. They are the few aspects that I wanted to highlight through this summary of the installed capacity. So in chapter 2, we have covered the RE integration process. So I will not go into the bidding phase, but right from when the developers approach CTU or STUs for connectivity, there is requirement for submission of all the technical data for verification of compliance. This compliance is usually verified against the technical requirements that are specified in the CA connectivity standards and other relevant regulations. So the basic requirements are the submission of test reports, the type test reports of single unit. Then based on the single unit test report, the single unit simulation model is prepared, and then it is verified against the type test results. Then that benchmarked single unit model is used to prepare the detailed model of the plant. And at this stage, only through the type test reports and through the simulation models and report, these are the only way to ensure the compliance. So it is of utmost importance that all these reports and modeling data are accurate, because if the performance of the plant and the IBRs does not the simulation response and the performance in real time, if it does not match, then we could end up with a surprise in real time. And that has happened in quite a few cases, especially in the events that we have covered in this report. So in chapter 3, we have covered the analysis of the grid events through measurement data. This analysis has been carried out mainly through the scatter data or the PMU data available at the regional and national load dispatch center. Here also I would like to highlight one thing, that as per the CA construction standards, the requirement of installing the PMU is at the pooling station or at the POI. But here we have, because of multiple regions, we have the PMU installed at the RE developer end. So this data has been used for the analysis of the events. Apart from this, we have also used the disturbance records, event logs, SOEs wherever available, as well as logs from the power plant controller also. This has not been very high resolution data, but still wherever these data were also available, we have tried to use them also along with the PMU data for substantiating our analysis. So before going into specific events, I would also like to cover the schematic of the ISTS connected RE in Rajasthan. So as I was mentioning earlier, we have these large pooling stations coming up with a lot of RE generation getting connected to these pooling stations. Then we have long lines from these pooling stations to other pooling stations, and all these pooling stations are in close vicinity. So a fault taking place at at any intermediate line will affect the RE generation at all these stations. And then we have long lines from these pooling stations to the load centers. So this schematic explains the scale of the reliability problem that we are facing. So right from ensuring the compliance at IBR level, we have to also ensure the transient stability issue all in this pocket, as we have long lines carrying a large amount of generation to load centers. So this is the scale of the reliability problem that we are dealing with currently with these large RE pockets. So the major insights from the measurement-based analysis, so 31 events, as I already mentioned, have taken place between January 22 to May 23. What was common between these events? We have tried to classify that into 5 categories. So the initiating event in some of the cases was a fault within the RE plant. In some cases, the initiating cause was a fault extended to the RE plant. In some cases, the generation loss was because of multiple faults within a short duration of time. So some of the plants were able to successfully ride through the first fault, but were not able to do the same in case of the second fault that took place in a short duration after the first one. Then we have been observing low frequency oscillations in voltage, especially in voltage and reactive power. And in these events, there have been some specific events where large voltage dips with no specific or periodic frequency were observed, and that has also resulted in generation loss in few cases. And then overvoltage in case of switching off any equipment like reactor or restoration of a line especially during peak solar hours. This has resulted in overvoltage and ultimately the tripping of the plants on this because of this high voltage. So some major observations are there have been no delayed fault clearance cases. Mostly faults have been cleared within 14-50 milliseconds. Then there has been a voltage rise immediately after the successful clearance of the fault. And coming to oscillations, there have been, we can also categorize them into 3 categories. The first one are with, oscillation frequency of 2 to 4 hertz and amplitude of around 0.01 to 0.15 per unit. Other ones are, very kind of low frequency oscillations with 0.3 to 0.8 hertz of mode of 0.3 to 0.8 hertz and amplitude of 0.01 to around 0.01 per unit. And then there are certain large variations in voltage, mostly voltage dips, without any periodicity. And the magnitude in these cases has been quite large, which has also resulted in voltage going below the LVRT threshold also in some of the cases. So coming to, we have covered each event of, we have covered one event of each type in this presentation. So coming to the first category of fault within the RE plant. So this event took place on 11th of August, where we lost 6,000 megawatt of generation in Rajasthan RE complex. So there was a face-to-face fault in a solar plant connected at the Bhadla PG station. So during this fault, the voltage went down to 0.76 per unit. This is below the HVRT threshold. Then immediately after the fault clearance, we witnessed very high voltages in the grid, and subsequently we lost around 6,000 megawatt of generation, which led to frequency dip of around 0.7 hertz. So if we go into the details, this is the fault that took place. The fault was cleared within the specified time. Then this is the plot of solar and wind generation in the northern region. Immediately after the fault clearance, we saw this generation loss of around 6,000 megawatt. And then after 5 to 6 seconds, we also saw some of the evacuating lines going out. So what happened because of which this generation loss took place, why this high voltage was observed? So for this, we have to go into the performance of specific plants. So this is the performance of a specific plant connected at Fatehgarh station. So during the fault, the plants are mandated to provide reactive power support, in order to arrest the voltage dip. But what happened in case of most of the plants, we did not, witness this reactive power support during the fault. Also, even though there was no reactive power support, there should some of the plant even the response was opposite to the desired one. So when the plants were expected to inject reactive power, some of the plants were even absorbing reactive power during the fault. Also, some of the plants which provided satisfactory response, the response came after the clearance of the fault or after the voltage had recovered. So all this resulted in high voltage after the clearance of fault. Another reason for this high voltage was the delayed active power recovery. So RE plants, they can as they have to provide reactive power support during the voltage dip, they can reduce the active power if the limit, the rated current limit gets exceeded. But in this case, there was almost minimal or opposite reactive power support from most of the plants. But at the same time, there was reduction in active power also. And then there was this delayed recovery of active power. So this delayed recovery of active power coupled with almost no or opposite reactive power support, this resulted in high voltage immediately after the fault clearance, which then caused most of the IBRs to enter into HVRT mode. Now at some of the pooling stations, the voltage was not even above 1.1 per unit. But the IBR level voltage might have crossed 1.1 per unit. So the IBRs entered into HVRT mode, which led to further reduction in active power generation. Then because of the lines, the long evacuation lines getting lightly loaded, the voltage increased further, and this further resulted in more IBRs going into HVRT mode, and then ultimately tripping off the generation, as well as the tripping of evacuation lines after 5 to 6 seconds because of the stage 1 over voltage protection operation. So similar event we also witnessed on 15th of May 2023, where there was a fault external to the RE plants. This fault was in the transmission network. a face-to-face fault took place in Bhadla Bikaner 765 kV line. The voltage dipped to 0.65 per unit, and then immediately after fault clearance, the voltage went within above the specified limits, and then again some IBRs went into HVIT mode, and then subsequently, due to the reduction in line loadings, the lines also tripped on over voltage. So the phenomena is kind of very similar to what was observed during the 11th August event. Now coming to the next category, which is over voltage due to reactor switching. So on 9th of Feb 2023, we witnessed 8 generation loss events within a span of 45 minutes. On the opening of a line reactor of Bhadla Bikaner 765 kV line, we saw a rise in voltage. That voltage rise was not, because of that voltage rise, the voltage did not reach near to the HVIT limits, but still we observed generation loss. So the first question that comes in mind is why the requirement of opening this line reactor arose at that point. So as we can see, as we have observed, because of the lack of reactive power support from some of the plants, we usually witness low. At that time, we witnessed low voltages during high solar hours. Because of this, we had to open, even the switchable line reactors along with all the bus reactors. So all the measures that we could take to maintain the voltage near to the nominal value. So all these were taken, and because during one such operation, we witnessed this generation loss of around 4,500 megawatts. So on opening of line reactor, the voltage went from 745 kV to 775 kV. This voltage was not near to the HVIT threshold, and there was no immediate generation loss also. But after 8 to 12 seconds of opening of this reactor, we saw gradual rise in voltage, and then subsequently the RE generation also reduced, and there was a loss of around 4,500 megawatt generation. So what actually resulted in generation, gradual rise in voltage after opening of this reactor, and the ultimate tripping of this large quantum of generation. So this is the active power of a typical plant during that period. So at this instant, the reactor was opened. Voltage was nowhere near the HVIT limits. The active power also did not reduce at this time, this point of time. But then we can see this gradual rise in voltage. This can be explained through this plot where the reactive power of the same plant is also plotted. So even when the voltage is increasing, we can see the reactive power. There is no reactive power support from the RE plant. The PPC response has been very sluggish in this case. And because of this gradual rise in voltage, we suspect that some of the inverters went into HVIT mode, and then there has been tripping of some quantum of generation, which again led to the reduction of loading in the lines, and ultimately tripping of many IBRs in the vicinity. So this is one of the cases where if the PPC would have responded properly, we would have avoided this generation loss. Another observation is that the voltage was well below the HVIT limits. Even then, some of the IBRs, they tripped because of maybe the higher voltage at their respective terminals. So did we get the answers that we were expecting after this analysis based on the PMU data? So why is there rise in voltage immediately after the fault clearance? The answer is because of no or opposite or delayed reactive power support from the plants coupled with the delayed active power recovery. This mainly results in high voltage immediately after fault clearance. The reason for dip in voltage after 5 seconds, there has been tripping of many EHV lines on over voltage stage 1 setting after protection after 5 to 6 seconds. And then why is there loss of RE generation? Because of this high voltage post fault clearance, we suspect that most of the IBRs are entering into HVIT mode, and then because there is no support from the IBRs even in the HVIT mode, So because of this, the plants or the IBRs are getting connected on HVRT. So this table provides a brief summary of, out of 44 plants, we can how many were compliant and how many were not complying with the specified requirements. So we can see that almost 50% of the plants, or even more than 50% in some of the events, were not complying with the requirements that are specified in the CA connectivity standards. Now I would request my colleague Mr. Rahul Shukla to take this one.
Thank you. Thank you very much, Priyam, for sharing your insights on the report. I am Rahul Shukla, and I will take you through the upcoming parts of the report, so chapter 3, 4, 5. And I would like to summarize these things and just continuing from where Priyam has left. So the chapter 3 of the report also details about the measurement-based analysis of grade events. So in that, we are witnessing some issues with the small signal stability within the RE pockets, and we are observing the low frequency oscillations. So we were able to capture the low frequency oscillations based on the phasor measurement unit data, which is providing us output at every 40 millisecond. Such a high resolution data helps us in capturing low frequency oscillations. So as we can see in the table given in the slide, we are able to capture the oscillations which are having different modes of frequency, oscillations with frequency between 2 to 4 hertz, between 0.03 to 0.1 hertz, and then 0.069 hertz oscillations where voltage magnitude is very large. So we can see the severity of the different modes. The voltage oscillation magnitude can give an indication that what is the severity of this oscillation. Any power system, it is very difficult to operate with voltage oscillations varying from 20 to 35 kV of magnitude. So it is very important the source of these oscillations are identified and mitigation measures are taken. So we are using that phasor measurement unit data to do our identification of the dominant mode in the oscillations using various methods like matrix pencil, fast Fourier, and STLS. All these methods are being used, and you can see on the right hand side, we have identified the dominant mode of these oscillations in the frequency spectrum. So again, during the analysis of the oscillations, we identified and we were able to pinpoint to an extent that the voltage controls which are implemented in the RE plants are not helping us to achieve the desired stable voltage profile. So we have categorized the performance of the RE plants into 3 categories. So the category 1 mentions that some plants which were already there in the constant power factor mode, they appeared as if they are non-responsive to the oscillations. Certainly, they were providing a limited reactive power variations, and since they were operating in constant power factor mode and in fixed power factor, it is very difficult to observe any variation from them during the changing voltage scenario. The category 2 power plants were those in which large variation of reactive power could be seen, but these variations were totally in phase with the voltage. So when there is a rise in voltage, there is an injection from the RE plants is in phase with the voltage, and thus voltages are getting again amplified. So these were not helping the voltages to smoothen, to stabilize. Rather, they were causing the oscillations. They were leading to the amplification of the oscillations. Then we had some category 3 of RE plants where the large variation of reactive power was out of phase with the voltage. So say voltage was increasing, then plants were reducing their injection or increasing their absorption of the reactive power. So thus they were trying to control the oscillations and smoothen out the voltage profile. Then from the measurement based analysis, we were able to arrive to certain conclusions, like to implement certain measures in the operation horizon, so that these oscillations can be mitigated, or the instances can be minimized. So we tried to modify our operational philosophy. In the short-term operational philosophy, we had taken few measures, like we started avoiding any major switching operation during during high RE generation period in the large RE complex. The Priyam has also shared one case study where the switching of a line reactor caused significant tripping of RE generation. So kind of we avoided carrying out any major switching operation during high generation periods. That has also helped us. So another part which we did was we took up the issue of HVRT and LVRT settings, and we came to we arrive at a conclusion that the plants were not able to observe the low voltage right through and high voltage right through. They were not able to sustain their operations because there were some differences in the opinion of between the plants and what regulations direct them. Regulations desire plants to carry out the right through based on the voltage at the point of interconnection. But the plants have implemented the settings of the low voltage right through and high voltage right through based on the voltage at the inverter terminals. So always there is a difference between the terminal voltage and the voltages at the point of interconnection. So we ask plants to modify their settings appropriately so that they are able to display the right through behavior when the voltages at the point of interconnection go to the extremes. So this way we you can see in the table also that we modified the right through setting requirements. We we give the recommendation to modify their settings, and certainly some plants cooperated and the settings were modified. In some cases, the voltage limits were increased, and in some cases, the withstand time was also increased. So in some plants, when we see the oscillations, whenever we observe the oscillations, we identified that their voltage controllers were not helping to mitigate the oscillations, rather they are magnifying the oscillations. We asked those plants to change their mode from the voltage control to constant reactive injection mode or a fixed power factor mode, so that they are not at least amplifying the oscillations during the instability. So another short-term measure what we have taken, that we asked certain plants to toggle their deadband so that their voltage controllers are not that sensitive to the voltage variations. In this way, we were able to minimize the oscillation cases. So all these measures are what we mentioned here are just the short-term measures which we took in the operational horizon and achieve somewhat a better power system behavior. So the chapter 4 of the report discusses about the simulation-based analysis of the grid events. It's again a comprehensive analysis based on the dynamic as well as steady state performance of the inverters. And in this, several studies, stability related studies for the RE pocket has been carried out. And those studies can be found in the report. Here they are summarized under the 4 heads. So first one is the analysis of the RE plant behavior. How RE plants used to behave and why there was a difference between the simulated RE plant model and the actual plant performance. So we came to know that the impact of collector system drop was one of the possible gaps where RE plant behavior and the actual plant behavior differentiated. Then again, there was an impact of K factor. K factor is a parameter in the voltage controller. So what K factor has been given and what K factor was implemented at the site, they were different, and that caused a difference in the RE plant performance. Again, the short circuit ratio, which RE plants had taken as a reference to tune their voltage controllers, were different from what short circuit ratio that was present at the site in the operating phase. In the operation phase, the short circuit ratio varies based on the different scenarios, load generation scenarios, and RE plants, since their controllers were tuned only to a particular short circuit ratio, they were not able to display that behavior accurately. So again, in the analysis of grid events, the simulation-based studies helped us in identifying that one of the reasons for which caused the difference from the desired performance was the delayed active power recovery of the RE plants. Second point was what was identified that some plants had large response time from what was the desired of them. Then in analysis of oscillations, it was identified that there were certain delays in the power plant controllers. Power plant controllers were not that fast so as to exactly follow the voltages. Then in the analysis, it was identified that different control modes available in the plants have different impacts, and control modes, tweaking of the control modes can help to achieve stability. Then deadband, droop were also identified as parameters which can be tweaked to do some tuning of the plant response. Then we have recently commissioned StatComs in the RE pocket, and one of the conclusions of the study was that StatCom settings also need to be tweaked, tuned appropriately so that they provide us a desired behavior rather than amplifying or magnifying the oscillations. So again, one of the important aspects in the RE pockets and one of the threats is the issue of transient stability. It is very important that the complete RE pocket during a fault event remains stable. From the transient stability point of view, we should be very much aware that such transient stability issues can cause a major tripping, where we can lose a large chunk of generation. A complete system can get desynchronized from rest of the system. So transient stability is something which was studied in detail in the simulation-based studies, and it was identified that certain improvements, certain setting changes can be adopted to help in the day-to-day system operation. One of them being we can place synchronous condensers in the RE-rich pockets because they are a good source of the short circuit strength as well as the source of inertia. And one of the findings was that we can achieve better response by keeping the plants in Q priority mode. When we were keeping the plants in P priority mode, the critical clearing times were getting impacted and were causing some instability related issues. So chapter 4, again, simulation-based analysis of grid events. So what were the deficiencies which were noted from the submitted models? So it was identified that a few developers had considered high short circuit ratios during their inverter tuning process, and those high short circuit ratios are not readily observed in the power system where they are operating as of now. In some cases, there was some improper modeling, like post-fault characteristics. There was the time constants indicated different recovery rate of active power, reactive power, but here some different settings were adopted in the models. So again, the same issue, the different K factors which were placed in the models and the K factors which were implemented at site was one finding. And again, in the models, the communication delays, the polling rate of inverters, update rates of equipments were not considered. So the actual performance was not matching with the simulated one. So these were the major issues. What were in the deficiencies which were identified in the submitted plant models. So major insights from the simulation studies, those have been summarized here. So it was found that there was a considerable difference between the inverter terminal voltage and the voltage at the point of interconnection. So how it was impacting the system. So we observed that even when the voltages at the point of interconnection were within the normal operating range, some inverters within the plant had entered the HVRT or the LVRT curve and started reducing their generation. So this way, this major insight was provided by the simulation studies. Then we could recommend an appropriate K factor based on the system strength. Based on the simulation studies, what will be an appropriate K factor to be implemented in the RE plants? So for low SCR systems and inverters with large response time, we had recommended different sets of K factor to achieve a desired response. Then converter parameters were tuned based on the realistic range of short circuit ratio. Short circuit ratio, if inverters are tuned to the short circuit ratio of 20, 25, 15, which it will be very difficult to achieve such short circuit ratios in the operational horizon. And CS standards also mention a short circuit ratio of 5, not less than 5. So plants have to tune their inverters within the operating range, within the possible operating range that could be near 5. So that feedback was given to the developers based on the simulation study results. And again, there was difference in the coordination among update rate of power quality meters, processing time update of power controllers, and falling rate of IBRs. This issue was also observed in the simulation that different equipments were having different processing time, different update time, using different communication protocols, philosophy. So all these coordination issues are required to be solved so that proper voltage control could be achieved by the simultaneous operation of all these devices. In the power controllers, the polling rate of inverter shall be as minimum as possible. This was identified because in some cases, the inverters were not able to receive the command from the power controllers since their polling rate was very high. So based on the simulation studies and simulation results, it was concluded that they should be taking the inverter should be able to take the command of the PPCs at very high rate. So again, high response time and delayed active power recovery in the LVRT curve, we can very easily see that very large response time may lead to the plant showing undesirable behavior during the low voltage right through curve. So this was also identified as one of the reasons. And again, based on the simulation studies, the P priority and Q priority modes based on the system strength, the feedback would be given. So chapter 5 and 6 of the report covers the details about suggestions and way forward. So different sets of suggestions for different entities have been mentioned. So all the stakeholders have been given certain suggestions. Suggestions are there for RE equipment manufacturers. Suggestions are there for RE developers. Suggestions are there at regulatory level to enhance and update the standards with the increasing RE penetration. And suggestions are for institutional capacity building to the stakeholders. So starting from the suggestions, first suggestion is that all equipment associated with RE plant, such as inverters, WTGs, IDTs, collector system and station transformer and associated cable, bus bar, all these should be designed to handle supply of rated active and reactive power under all ambient conditions prevailing at sites. So The RE developers shall ensure that all their equipments are able to withstand display the desired performance under all sets of ambient conditions, and all their equipment shall not cause any hindrance in displaying the desired performance. So this was one of the major findings. And another is that in this complete setup, we can see a lot of electrical equipments are there. A lot of from the 220 kV bus is there, 33 kV bus is there. Again, 700 volt system is there. So all these are having their own set of protection systems. So it is very much important that all sets of protection systems are coordinated in such a way that in their simultaneous operation, they are able to display the desired features, desired performance at the point of interconnection. So a recommendation was given that protection settings of inverters, WTG, should be coordinated in such a way that they are able to withstand the voltage experienced at their terminals corresponding to the extreme voltage limits at POI. So the behavior is desired for the voltage levels at point of interconnection. So their equipment should be tuned accordingly that the voltage at the point of interconnection goes into extreme. Complete set of equipment are coordinated to display that performance. Again, suggestion for RE developers that RE developers shall ensure that type testing of equipment is carried out so as to comply the CA standards. Type testing is very important aspect, and that should be carried out by accredited agencies so that the equipment in its lifetime shall be able to display the desired performance. Any quality compromise would be checked at the pre-commissioning stage itself. So equipment should be type tested. Shall ensure the availability of statement of compliance by IC accredited agency. These all things at the pre-commissioning stage, like statement of compliance, monitoring, can help us in avoiding the issues during the operation phase of the plant. So again, RE plant shall prepare the model of the park and ensure the availability of CA regulation compliance certificate from an accredited agency. So all these things are important from the point of view of RE equipment by the developer, selection of appropriate RE equipment by the developer. So the next point is protection of inverter terminal and coordination with POI. This has been explained. One point remains the same, that during the voltage measurements at the point of interconnection, any protection based tripping which requires, say, immediate tripping of the equipment, say for the high voltage right through, for the voltages above 1.3, there is a provision for immediate tripping that should not be dependent on the sub-cycle measurements. At least 1-2 cycle delay should be there so that some RMS value or some appropriate values are there so that in the transients, equipments do not get tripped. Suggestions for RE developers. Again, the RE developers during the post-facto analysis phase, it is found that the high resolution disturbance recorder data is not available with the RE plants. So we request and we found that in the report that all the RE plants should be having a provision so that to install an equipment where it is possible to capture the disturbance records with a resolution of around 1 millisecond. So this is also one of the important points. So the configuration of converter and plant control, that should be set as per the operating conditions of the grid at that point where the plant is located, and a realistic value of short circuit ratio which is near to actual should be utilized while carrying out the interconnection studies. One suggestion is for cyber security guidelines. Compliance of cyber security guidelines is very important because it is possible that few plants can be operated from remote, and that can cause really big problems in the real-time operation. So from international learnings and for the strengthening of Indian standards, few requirements have been mentioned based on the literature survey from the international best practices, like in the design requirements of the plants, like in the definition of the interconnection point, that all the compliances need to be at point of interconnection. It is there in the standards. So a detailed diagram with the labeling of the point of interconnection, which are there in other standards, could be given. Then there is a reactive capability, how reactive capability is there in the different standards. What is the voltage right-through requirements? There are more detailed, elaborate voltage right-through requirements in other international standards. And thus ramping requirements as well as power quality requirements, these are also in detail. So like voltage right-through requirements, our requirements are also comprehensive, but to elaborate them further, certain points can be adopted, like reactive support based on the severity of voltage depth. There can be a mention of response time for receiving the desired response. In case of LVRT, HVRT, in our standards, it is written that reactive power will be given first priority, but the part that active power reduction, what shall be the limit of active power reduction and what shall be the extent to which plants can reduce, that is not exactly specified. So mentioning them could help in the standards. Again, for the HVRT, a suitable margin shall be kept so that there is always this gap between the voltage at the point of interconnection and voltage at the inverter terminal. So this gap should be taken care of and it should be appropriately specified for providing the more clarity. As of now, these things are available in our standards, but further clarity can be added based on the what is available in the other power systems. So short circuit ratio metric, this is very important and most significant input which is to be used in tuning of the controllers. So short circuit ratio, which is defined as of now, does not comprise of those details which is required for carrying out the integration study of inverters. So different metrics are there in different power systems. Those can be adopted and or a mixture of them could be adopted, like short circuit ratio, which is right now being used in our power system. It simply does not consider the impact of other nearby inverters which are there to that particular inverter. Suppose an inverter is getting integrated at one point, the behavior and its interaction with other nearby inverters should be studied, but the adoption of simple short circuit ratio term fails to acknowledge this thing. So other metrics like composite short circuit ratio, weighted short circuit ratio, and multi-in-feed short circuit ratio, we can see they are having added advantages, and multi-in-feed short circuit ratio has been found to be most appropriate to identify the interaction with other nearby inverter-based resources. So again, next is the reactive support, what is mentioned in our standards. We can see this is a simple triangular curve with requirement of 0.95 power factor lag to 0.95 power factor lead. So what plants have done, plants have limited their response up to this level only. But as we know, at the lower output levels, plants are capable to generate or capable to exchange more reactive power than that. And certainly an added margin would help us in operating our power system more efficiently. So we can see that the inherent capability as available in the curves given on the right, there is a possibility of tapping that resource, tapping that extra reactive power which is available in the RE plants in our day-to-day operations. Again, for the power plant controllers, several interactions were discussed in this slide as well as in the report, that there are different timings, different parameters have caused oscillations, caused small signal stability. So there are different sets of parameters and their communication delays. They all need to be tuned so that the plant is able to provide us steady state voltage control as desired in the CS standards. So all these parameters and all these performance metrics need to be defined and need to be elaborated in the standard. Again, standards for disturbance records and data retention. This is again a challenge because several plants complain that if we are storing and if we are archiving the data, how much time we have to archive that data. So certain set of standards would certainly help that data has to be retained by this number of days and data retained should be of this resolution. So best practice could be evolved for different sets of data like sequence of event recording, digital fault recording, dynamic disturbance recording, inverter fault codes. All these data along with their resolution and data archival retention time should be mentioned. Then requirement of PPC as of now is only for RE plants with generation capacity of 500 megawatt and above. So PPC again is very important part of an RE plant for voltage control and frequency control features. So it would be better if we have a PPC to be mandated at all the plants with an aggregate installed capacity of 50 megawatt and above. Then with the expected integration of battery energy storage systems, we have large major plants. In all the CA reports, we see a large chunk of BESS coming into the picture. So all the requirements which are available for the wind and solar generation plants should be evolved on a similar lines for the battery energy storage system, since these resources are also inverter based resource and a huge fleet is expected to be commissioned in coming years. Certainly with the expected commissioning of electrolyzers, the standards need to be evolved for them also. Standards need to be evolved for the grid forming capability of inverters. What inverters we are having in our Indian power system are mostly grid following type. And in grid following inverters, it is again the challenge difficult when the grids become weak and when their penetration become more and conventional generators retire, it becomes difficult to ensure the system stability with them. So certain chunk of generation out of these RE plants which are expected to come in future need to be of grid forming type. Grid forming type inverters have proved to be beneficial in under high RE penetration regime. So these can be thought of. Then with the expected high distributed energy resources up in the future grid, certainly detailed standards on similar lines may be evolved. Then for the capacity building, this is really important since all these resources are inverter based and the power system operation as well as the plant operation with these resources require in-depth knowledge and understanding of the performance of these resources. So complete institutional capacity building is required. Under that, certain points are important, like for the testing and type certification of WTG's inverter-based resources for compliance of the CS standards, certain framework need to be drafted and adopted for Indian power system, because most of the plants, they are getting type testing and certification from foreign agencies, and certainly a detailed framework and its availability in India would help, since a large chunk of RE is expected. Again, agencies within India, they need to be developed for type testing and certification, and they need to get their accreditation by any of the government agencies like CA, NIVE, NICE for testing and certification. So human resource development or for the personnel working in the renewable energy sector, that is also an important aspect, and they need to be evolved, and the personnel working at the control centers, the personnel working at the RE developers sites, all need to be well conversant with these new technologies, and shall be able to carry out the simulation based studies, and shall be able to retrieve the data and do the post facto analysis themselves. So this was all from our side. Thank you very much.
Can you explain what is the reason for the phase to fault? Do you have any data on why the phase to phase fault occurred and so on?
Not on the solar plant itself, phase-to-phase fault occurred on the transmission line or the dedicated transmission line, which is at the 220 kV levels.
Which is on the transmission line, which is 6,000 megawatts.
Yes, one fault at the RE-rich pocket has resulted in the reduction of generation of the other RE plants, which were far off from that plant. That has resulted in the generation loss. So it is not exactly like line has tripped and its generation has tripped. It appeared as a voltage dip to the complete RE pocket, and that voltage dip was observed across all the pooling stations. And since the pooling stations observed that voltage dip, the RE plants which were connected behind those pooling stations treated it as a signal to enter into the low voltage ride-through zone, and the plants entered into the lower voltage ride-through zone. They reduced their generation, and the generation got reduced. And by the time generation got reduced after the reduction of generation, the behavior was not satisfactory. What was expected out of them as per the CN standard, they were not able to inject the reactive power or to restore their generation within 1 second. That resulted in again a very high voltage, and during that high voltage, plants again entered into high voltage ride-through zone and reduced their generation. And this way, severe high voltage got built up, and the evacuating lines tripped on the over voltage stage 1 protection. Then voltage came down, and after that, plants started.
So how long the plant was out actually? The plant?
Plants are basically out for say at a minimum of say if they get tripped on high voltage, they are tripped for a longer duration. Say it depends based on plant.
It's not a major blackout.
No, it was a major disturbance. 6,000 megawatt was lost.
Yeah, major disturbance, but not.
So for 5 minutes also, the 6,000 megawatt loss even for 5 minutes is major catastrophe.
Yeah,
frequency dipped to 49.40 hertz, the level 1 of say under frequency load shedding.
And I think currently the CEA or BAS has no mandatory DFR included on the plants, right? Any plant, so any solar plant. Most solar plant is actually installed digital fault recorder, right, at the moment.
Plants have digital fault recorders on their transmission lines, dedicated transmission lines.
All the plants.
On the dedicated 220 kV lines.
That's a grid.
Within the plants, the inverters have inbuilt feature also. Several inverters have inbuilt feature also, but there are problems in sharing and archiving of those details. They need not go for extra installation of equipment. Those are available features in the inverters and the equipments of the RE plants, but there are some issues in the sharing and retention of those data.
And one more point is that inverters mentioned in the document, are they central inverters or string inverters? Because many plants are actually using both.
Yes, actually, many plants many plants are of string inverter type, but few plants are central inverter type also. That depends on size. When we go for the string inverters, obviously the sizes are very low, 0.4 MVA, 0.7 MVA. For central inverters, we are seeing 2.5 MVA, 3 MVA. Again, in the string inverters, what becomes difficult to manage the voltage within the plant because there are large strings. An inverter which is far off from the plant's high voltage bus may experience extremely high voltages rather than inverters which are near to the high voltage bus. So string inverters do again face this difficulty. Central inverters, this is less on.
Sir, this is Giridharan from Hitachi Energy from the audience, and am I audible to you?
Yes.
Sir, I have a question. I think you have presented about the need of grid forming control on the inverter side. Are there any definitions as such for the grid forming? We have it in the grid code, sir. I mean, like especially it's not only for the inverters and also maybe any, for that matter, any elements that are connected to that Indian grid. Do you have any such grid forming controls that you would like to define, or maybe you are in the process of defining?
So actually, we are from National Load Dispatch Center, that is under Grid Controller of India. We are grid controllers. We are adding that as our operational feedback. So as of now, grid forming inverters are not available in the regulations, but we expect that same will be added, or it will be under discussion since we have discussed the requirement for the Indian grid in our report as well. So it all depends on the future, how things turn up. But yes, they are required, and all the standards, you can refer the UK grid code where we have the requirements of grid forming inverters.
Yes, sir. I mean, like different countries has got a different meaning for the grid code as such. I mean, like, but there is no such standard defining what is grid code. I mean, sorry, what is grid forming control for the. I mean, as such in general, it is not available from the standards perspective. It is more of like the definitions are customized to the respective grids. Actually, I mean, it is the onus is passed on to the grid owners and operators. So that's why I asked this question.
Okay.
Thanks.
Okay, two questions, I think slightly related to this. Okay. For the last couple of years, okay, many solar plants are experiencing inverter duty transfer failures. Okay. And it happened in Europe since 2012, and it is happening in India recently also, but nobody is coming to share the data. And SEGRE A2, working group, I think A68 working group, they initiated survey, worldwide survey of IDT failures to come up with suggestions and guidelines. Okay, so do you have, it means the Grid Controller of India or Central Electricity Authority, do you have any data on this? What is the situation? Because in India, we have one solar park in Karnataka, another solar park in Andhra, okay? And we visited some of them. They have experienced in one plant, it's isolated incident. In another plant, it's multiple failure of inverter duty transformer within the warranty period, and that manufacturer did not replace even after the failure. And currently, there is no existing standard for IDT. Okay, IEEE has one standard, and it is not complete. And one more point that I would like to share is that we have done a study that all these inverters, IDT inverters, they emit supraharmonics. And we don't have a device to measure supraharmonic, and our standards to measure harmonics up to 50th one. And the impact of the supraharmonics, nobody has investigated. So in future, moving forward, this will be an issue where you are experiencing some grid disturbances. Many other incidents can happen if you don't revise standard or conduct a study. What is the impact of this?
Regarding the first question of inverter duty transformers, we have visited the site as well, and we discussed with them. As of now, none of the RE developers have approached to us that or informed to us that they are facing the multiple failures as of now. In the event disturbances also, we were not able to capture, or we haven't had any information about the inverter duty transformer failures. But yes, standards are not only required for the inverter duty transformers. What we are mentioning, as in the slides also, that a complete plant, all the equipment should be standardized so that they are able to display the desired behavior during the extreme events like LVRT, HVRT. Other than that, what happens within the plant, inverter duty transformers, those are at very low levels, 2.5 MVA, 11 MVA, like that. So we do not go inside of those details of the plant, being a grid controller. So, however, in the CS standards, we expect very soon to have detailed requirements for all these devices, including the inverter duty transformer, because that has been identified in our report also as an important equipment for the RE plant. So we expect that the IDT standards very soon. Second part regarding the harmonics, in Indian power system, and as per the CA requirements, the harmonic are there, harmonic computation as well as harmonic checking is there. So yearly, and that time duration is also mentioned. IEEE 519 is to be followed by
519 is very old.
No, it has been updated. They had revised it. It is 2022. The latest version is 2022, and the plants have to follow IEEE 519 2022. And those details are very elaborated. And apart from that, 2022 gives an indirect reference to IEEE standard 2800 also for measuring of power plant harmony. So I feel those are very clear, and 519 is mentioned in the CA regulation.
No, I understand that. 519, whatever is mentioned, it is applicable. The distribution system, PV penetration coming in. Coming in. So distribution side, it is required. You cannot apply same rule of PhD calculation on the transmission side and the distribution side. Because in the distribution side, because of various types of inverter, grid forming, this, that, swing inverter, central inverter, supra harmonics are coming. New devices are actually measuring, and they are, as per IEC limit, they are exceeding it. But nobody is having that information, nobody is sharing that information.
So we are not the right authority to comment on that. Certainly, this distribution, but again, I would like to add that CA standard 2specify for distribution licenses also. There are power quality requirements also, those are mentioned in the regulation. But I cannot comment what is the status since we are not having those details from the distribution side. Priyam, you would like to add?
No.
Yeah, good evening. Good evening. I'm sorry for that. I just wanted to ask that you have analyzed, there is a case of fault right through, and there is a case that there is a voltage surge whenever the reactor is getting open. Why these events are not analyzed with respect to unintentional isolation of the inverter or anti-islanding protection? Why they are not coordinated? Why there is no coordination between these two events while analyzing that?
So it is not like there is no coordination or we are not analyzing these aspects also. Major issue is regarding the IBR level data also. So this has been the major challenge in analyzing all these events, and we have also highlighted this aspect in our report also. So wherever these details, the IBR level details were available with us, we have tried to analyze what has went wrong, whatever our analysis is based on the measurement data, whether it be the PMU data or the SCADA data. We have tried to verify it against the PPC log, against the inverter logs also, whenever the data was available. But as we mentioned, the data availability has been a major challenge, and this is why we have not been able to, kind of complete the loop, going down from the POI level analysis to the, IBR level analysis also.
I would like to appreciate the effort Grid India has taken for performing such complicated analysis and giving us a lot of insightful information. For that. So my question is, since this penetration of RE is coming up and RE amount is adding up every year, which is indirectly the system inertia is going down.
So what is the operational plan or operational philosophy of like from the grid stability point of view in terms of frequency stability, in terms of inertia support and in terms of frequency control, how Grid India is looking stability of the grid in coming years?
Thank you. Thank you for your appreciation. Regarding the inertia, Grid India has released a comprehensive report on the assessment of inertia in the year 2022. So inertia is expected to decline, but as of now, we do not see a major problem regarding the inertia aspect. So in the coming years, inertia is expected to decline. So regulators are also aware of that. And if you will go through this Indian Electricity Grid Code 2023, inertia has been defined and requirement of inertia has been defined and what actions grid operator has to take when inertia is not sufficient for the system. That is also those actions have been elaborated in this IEGC 2023. So we are very much aware of that as a system operator and grid controller, and regulatory bodies are also aware of those requirements. In the planning stage also, studies are being done so as to factor this inertia aspect. The pockets where inertia is expected to be very low, certain appropriate measures have been taken at the planning stage.
One more question. After performing the simulations, you have given certain recommendations like the K factor adjustment and PI controller setting, optimization and tuning. Was further data was analyzed after this implementation being done? Like improvement is noticed?
Yes, definitely, and it's a great question, and we have tried to do that. If we look at the events that have taken place, say after August or after May, we have compiled all the events that have taken place till May 23. So the frequency of the events has certainly reduced for the same dip in voltage. Now we are witnessing generation, though we are witnessing some generation loss, but the quantum has reduced significantly. One of the major reasons has been we have revised the settings, IBR level settings for HVRT and LVRT, because the plants have to comply with with all these provisions at the POI. So the reference point is the point of interconnection. So if the voltage at POI goes above 1.1 or below 0.9, then only the IBRs shall enter into HVRT or LVRT mode. These settings were earlier kept at individual inverters. So now, as most of the IBRs, they support the grid through reactive power injection during the high generation period. The voltage is, in most of the cases, is higher at inverter terminals than compared at POI. So even when the voltage was not crossing the HVRT threshold at POI, the inverters were entering into HVRT mode, and we were seeing the tripping of these inverters. After revision in settings, we have seen that some of the inverters that were earlier entering into HVRT mode and tripping on HVRT, they are now not entering into HVRT because of these revised settings. K factor also we have tried to modify in some of the cases, because especially when the response time is large, and if the response is not coming during the fault but after the recovery of voltage, then also this will lead to high voltages in the grid. So if we reduce the K factor in the plants where the response time is on the higher side, so if the response is also lower, then the voltage rise will also be within limits. So these are few changes that we have done, and we have seen the results also. Can I have a question?
Yes.
Good evening. It was really insightful presentation, and really appreciate it. And my name is Arvind Gupta. I am quitting independently. I am Global Knowledge is my company, which I just opened, and my job or what my plan is that I want to do complete teaching and research independently and try to bridge the gap between academy and industry. Because when you're working in an industry or in academic institutions, there are a lot of responsibilities which we are not able to cater. So that is what I have been trying to do for the last 5 years. And actually I was successful, but now I think with 5 years experience and with a lot of interactions which I am independently having with all the various organizations, all the plants, power plants, and of course, I have not been able to interact with today. I think I have interacted with some of the people from Grid India, but otherwise, I have been in touch with other power plants and academia. And my question is that the power quality, when we're talking about, we have standard like 5% of current harmonics or THDs to be limited. Now, but that is probably when I think standards or even CA is telling that this 5% is there, but when it is rated, it is fine. But when the load is coming less, that is that whatever the solar and wind is less, and then you have less injection to the grid. At that point of time, I think that harmonics are definitely not 5%, it is far more than that. It could be 50, it could be 100% also. And I don't think currently we have anything to have dynamic or the online monitoring of those things. And what are the effects of those power quality issues in the long term on the equipments and the life? I mean, that is something which I feel is a gray area and needs to be looked into. So anything on that you are thinking of proposing? Just it is my academic question.
Yes, good question. Certainly, the power quality is being measured. It has to be measured as per the CA standards. You very well mentioned that THD limit, total harmonic distortion limit, should be within 5% say for load. So different scenarios are possible. Sometimes wind can be high, sometimes it can be low, sometimes some other nearby generator will be there, sometimes load will be having different set of things. So as of now, we, as mentioned in the presentation also, we are not having that high resolution data. When we are talking about harmonics, we certainly require those millisecond accuracy data. From the PMUs, which are available at 40 milliseconds, it is very difficult to comment upon or say something about them. Power quality based tests, which are mandated as per CA standards, are time bound to be done at specific durations, specific intervals. It is felt that those are appropriate to cover the details because 7 days time window is there in 519, IEEE 519. So in 7 days, all these aspects can be monitored, can be, the grid will see those things, what you are mentioning that during low generation periods. So a 7 days period is quite comprehensive one, and we assume that those are there. And other than that, during the pre-commissioning stage, as a requirement of first-time charging, we are also identifying, validating the plant models in the frequency domain for the harmonics. So in the PSCAT and EMT models, all the available EMT models, we are using that to identify the possible harmonics and the power quality of the plants. Priyam, you have anything to add?
Before the commissioning of the plant, the verification that all the parameters are within the specified limits. The power quality assessment is done in the simulation domain. After the commissioning of the plant on annual basis, based on the site measurements, the compliance is being verified. So this is the process at present. Also, regarding the impact of these harmonics on the life of the equipments, that as of now in the major RE complexes, we have not seen any case of any equipment failure or damage because of the harmonic injections. But yeah, we are keeping an eye on that, and we are doing various checks in the simulation domain as well as through site measurements. And definitely this is one area that we will be keeping in close eye.
Okay, just to add on that, I have done some power quality studies in one of my R&D labs, and I was really surprised by the type of data which I got from that. So that was so bewildering. It was looking at everything is fine, like in this room, but if you put the three-phase analyzer and PQ analyzer and try to see the different type of parameters available, even harmonics were there, and there were so negative harmonics and so many complicated things. Harmonics was there at that point of time. What was the load in my room? While so that got me into that we are so not, because it is something we can't visualize very easily. It's only that measurement from the PQ meters are the only ones which can do that. And as you said that your PMU wouldn't be doing that. So PQ meters, the installation of what is that and how much we are, I think online PQ meters, whether they are mandatory or not, I have no idea. But probably these are the ones because they are going to have certain impact. This is what I could see from my LV side. But at higher levels, definitely things would be something. So this is in the process of exploring. I am in the process of exploring the power quality currently. So anyway, it's good that we have talked on that.
Plants are having power quality meters, power quality analyzers. As we shown in our slides also, the power park controllers, the data fetching part, equipment which is fetching that real-time voltage, real-time reactive power from the point of interconnection or a high voltage side of the RE plant is power quality meter. And certainly those are having very good archival facilities and harmonics can be seen. So they are there, power quality meters, and certainly as per the CA requirements, everyone has to comply with that.
I am from Center for Global Knowledge and Research. That is my own company independently have opened. Yes.
You need anything on power quality concept. I've been working on this area for last more than 25 years.
Okay, right. Thank
you. Thank you very much.
Thank you, Priyam Jain sir, Rahul Shukla sir, for your outstanding contribution and very informative and important presentation, please. Ladies and gentlemen, we now start the panel discussion on the subject of way forward for reliable operation of our grid. It is especially a great moment for all of us as we are being joined by 5 esteemed professionals as panelists who will be sharing their valuable views and accentuate our knowledge with their vast experience on this subject. Ladies and gentlemen, may I please invite all the esteemed panelists on the dais. Shri R.K. Porwal ji, Director, System Operation Grid India. Shri Hemant Jain ji, Chief Engineer, CEA. Shri Kashish Bhambani ji, General Manager, Central Transmission Utility of India Limited. Shri Atul Kumar ji, Executive Director, Operation Anaya Power, and Shri Mukut Kumar ji from Tata Power Renewable Energy Limited. Ladies and gentlemen, let's please welcome them with a huge round of applause. Thank you very much, sir, for joining us. For moderation, may I please hand over the floor to Shri Vivek Pandey, sir, General Manager, Grid India.
Arun Kumar is online. And Mr. Mukul.
Hi, how are you? Hi, I have joined online. Yeah, thank you. Yeah. Hope you can hear me.
Yes, sir. Thank you. Thank you for joining.
Mute until that time.
It's my privilege to welcome you all to this panel discussion. It has been a very, very interesting discussion so far in the last 3 webinars that we had. Several aspects have been highlighted by the speakers. The analysis of various grid events that have occurred in the recent past have brought out issues that need to be collectively understood, and then as all the stakeholders need to put together efforts to identify and implement the countermeasures to enhance the reliability of the grid and also to accelerate the addition of renewable capacity in the grid to achieve the targets for energy transition that has been set forth collectively. So So I'd like Ms. Kala to just introduce our esteemed panelist before we proceed for the discussions.
Thank you, sir. So our panel members are Shri Rajiv Kumar Porwal. Shri R.K. Porwal is the Director System Operation of Grid India. He is a 1992 batch graduate in electrical engineering from Madan Mohan Malviya Engineering College, Gorakhpur, and a master in power electronics, electrical mechanics, and drives from Indian Institute of Technology, Delhi. Before joining the board of Grid India, he was working as executive director at Northern Regional Load Dispatch Center. Shri Rajiv Kumarji has immensely contributed during rolling out of major initiatives like security constrained economic dispatch and automatic generation control in the country. He has played a vital role in the cross-border power exchange with the neighboring countries, drafting of the expert committee report for the Grid Code 2023 and integration of renewable at the interstate level. He has co-authored more than 25 technical papers at national and international forums. He is member of IEEE and SIGRE, wherein he has contributed to the working groups. He has been appointed as Director System Operation of Grid India in July 2023. Our next panel member is Shri Hemant Jain, Chief Engineer, Renewable Project Monitoring Division, CEA. He has done his BTech in electrical from Madan Mohan Malviya Engineering College, Gorakhpur, and MTech from IIT Delhi. He has joined CEA, Government of India, on 22nd February 1991 as Assistant Director in Central Power Engineering Services, Group A cadre. Mr. Kashish Bambani, who is also the panel member, is currently the General Manager in Central Transmission Utility of India Limited, a subsidiary of Power Grid Corporation of India Limited, and looking after Northern Regional Transmission Planning. He has over 25 years of professional experience in Indian power sector. His core areas of expertise include power system modeling and simulations, integrated transmission system planning and its development, as well as grid integration of renewables. He was associated in planning and development of a large number of EHV transmission projects in India, including high-capacity transmission corridors, green energy corridors, REMSCs, major HVDC project, FACTS, devices, as well as 1200 kV national test station. He has published numerous technical papers in SIGRE, NPSC, etc., and recipient of this year IEC 1906 award for his exceptional contribution in formulation of TC 122 standards. He also contributed in invention of FPGA-based microgrid control and monitoring system, which has been accorded a patent in August 2023. The next panel member is Dr. Arul Kumar. He is Executive Director Operations, Anaya Power. Dr. Arul is an accomplished professional with over 25 years of experience in the technology, EPC, BD, and manufacturing sectors. With a diverse background spanning roles at top-tier organizations such as Tata Power Solar System Limited, Tata International, and Applied Materials, Dr. Arul brings a wealth of knowledge to his current role as Executive Director Operations at Anaya Renewable Power Limited. His impressive academic credentials, including a BTech from IIT Madras and MS and PhD from Cornell University in System Design and Controls, and he has a distinguished achievement of having 40 US patents under him. And Mr. Mukund Kumar, he is graduated in electrical engineering from National Institute of Technology, Jamshedpur in the year 2004. He has joined Tata Power since then and worked at various thermal transmission distribution division on project testing and commissioning. In the year 2017, he has joined Renewable Division of Tata Power and working as head post bid engineering since then. Thank you.
Thank you, Ms. Kala, for that introduction. So now we coming to the discussion. As we were going through the presentations in the webinar as well as today, there's one thing that is very clearly evident, that in the operation phase, there are certain issues that are being experienced. And as grid operators, the first question that I would like to invite Mr. Porwal, who is the Director System Operation in Grid India, to seek his views on what does he think the challenges that we are facing right now, what could be the possible ways in which we can address those challenges in the operational phase. Are there any aspects which can improve the coordination which has been identified. For example, several protection coordination related issues have been identified. The report has identified one particular area, like there were lack of awareness of the standards itself. So what as a head of the system operation wing in Grid India, what do you think, sir? What could be done to improve this situation? How could we move ahead from here?
Thank you. Thank you. Basically, from the operational perspective, what we need to do is that information of all these, what are the devices, what are the moral system, this need to be given a priority. And the equal amount of time at the plant level is also equally important, so that at the last moment we do not face a challenge. The regulations which are currently in place are also quite elaborate, and compliance to those regulations become extremely important to avoid such large scale issues. As we have been say formulating the first time charging procedure in Grid India, and there has been a lot of see, it is not for that we unnecessarily require a lot of data, but it is for the benefit of the entire sector, that any issues which is likely to come up is being identified and mitigating measures are being taken by the different stakeholders. So those are the extremely important. And as far as future conditions are concerned, that okay, in future some changes in the regulations will be required. That is an ongoing process that we need to do that faster mode in whatever the learning has been. Those learnings taken into account quickly, and quickly some of the, as in the past also somebody was explaining that we don't have presently the standard for the grid forming inverters, or for that matter, our BESS, etc., will be coming into the system, or for any requirement for the, say, large scale electrolyzer integration into the grid. So all this will also, how fast we can have the forthcoming, forward-looking standards, and then necessarily compliance to the standards, and further we also need to have a lot of capacity building in the at the all the levels, at the plant level, at our CTU or Grid India level. Everywhere we need to have continuous capacity building also to improve the reliability of the system.
Thank you, sir. I pick up quite a few points from there. One that we have emphasized regarding compliance, verification, and its enforcement of the technical standards. That is one area that is very, very important. And you have certainly rightly pointed out this awareness and capacity building in this area. So now from what I understand, and we all know that at present, the connectivity to the grid and the first time charging approvals, these are the two stages wherein these things are very carefully checked, and only after ensuring that the RE plants are complying, they are given necessary approvals. So my question to Mr. Kashish, as a part of CTUIL, what do you think are the technical challenges that you have been facing during the planning stage, and what do you think could be the way ahead to mitigate those challenges, and what could be done along with grid operators and planners? How can they both coordinate and ensure things move in the right direction and everything is ensured, the reliability part is ensured?
Thank you, Vivek. So just to answer that question, first of all, there is too much of interest in Rajasthan. Because too much of land availability at very reasonable prices. Everybody is after Rajasthan because my fellow RE developers are also on it, so I would like to address these issues. I I'll just go to the past a decade ago when we started the first project GEC. And the GEC was the first ever comprehensive project on RE integration. At that time, we used to have around 25 gigs of total RE, around 10% of penetration. In Rajasthan alone, we had 2 gigawatts only, wind and solar. But now, if we see what has happened after a decade, it has gone 22 gigs. So the important part is Rajasthan is becoming a major power hub from all perspective of RE. And that too mainly concentrated to the BBF axis. We call it BBF axis. It's a Bikaner, Bhadla, Fatehgarh axis, which is around 300 kilometer by 300 kilometer area. So as on today, if you see, the Rajasthan is the only state which is having so much of volume of generation in such a concentrated manner. So that's a major and big challenge. And that's not being stopped. Right now, in CTO, we have around 65 gigs of connectivity already with us. So you can imagine that what has happened in past 10 years is going to be happening in much sooner than that by 2028 or 29. So that's a major challenge for us, that it's becoming too much of concentrated. And from the RE grid integration point of view, the best part should be that it's geographically dispersed. The lowest cost of integration only comes when there is a dispersion of resources. And it not only gives in the least cost optimization or grid integrations cost, but also it gives diversity of the issues which is happening currently in Rajasthan. Be it the cloud cover, which has impacted us for 7 gigawatt in past some time, which nobody anticipated ever. When we devised even REMC, we used to think that, okay, only 2 gigawatts will go or only 1 gigawatt will go because of the cloud covers. But nobody ever thought that 7 gigawatt of entire generation of so much of volume, it will lead to a disastrous impact on the grid. So yes, we are getting so much of application in Rajasthan, and that's a major challenge for us. And how we are encountering the second issue with the transmission planner is the mismatch of generation. In Rajasthan, too much of generation is coming very fast. 18 months, say 20 months, people are coming up. So even before transmission is ready, they are lining up their projects. So that's a major challenge for us to how to get them evacuated, because once the project is ready, then it becomes very challenging for us to say no to them, for us to enter grid India. So that's a major challenge, that how to convince them to just align with the transmission schedule. And when it happens in a concentrated manner, definitely the transmission requirement becomes more. The right of way, the land issues which we are encountering in the Rajasthan, that delays the project. So right now the projects are definitely getting delayed because of the concentrated and more transmission planning in one complex. So that's extremely challenging. So in past, we adopted the REZ approach, in which we planned the system ahead of generation, so that at least the mismatch part can be addressed to some extent. But again, the kind of interest what we are having, around a month, we are getting around 4 to 5 gigs of applications. So you can assume that how fast paced it is. And definitely the planning is being done in that way. And we are extremely, concerned about that geographical concentration in such a manner should not happen. Or if it has to happen, it has to happen in phases, not at one go, like next 3 years we are having 3x, because that will also give some of the leeway or some of the breath to take back what has happened in our grid, how we can mitigate the challenges. So that's one part. We also anticipated that BSS will come up along with RE as part of the CA 181.5 reports, but it didn't take off. So it's pure vanilla solar which is coming up in the system, and that's really very challenging. And though we are planning to our best of knowledges, be it through STATCOM, SPECS devices, or HVDC LCs, or say synchronous condenser, which are upcoming. But definitely, we would like to have more and more things to be covered with 65 gigawatts of connectivity ensured. But the point is that concentration of anything too much at one place is definitely challenging for both of us, from the planners as well as grid operation point of view.
Yeah, thank you. Just a follow-up of a few points that you have mentioned. We have also seen the 500 gigawatt transmission plan report that has been published, and it gives a very good insight and view of what are the elements that are coming up and what kind of equipments are going to be integrated. Most of this will all lead to increase in the inverter-based resources, whether you talk of STATCOM, whether you talk of BESS, and then even there is a plan to have HVDC lines, LCC, as well as VSC lines coming out from RE pockets. Literature speaks that there could be potential controller interactions. So I'm sure these aspects would have been examined. So what do you think, what could be, what is being done, and how we can ensure that those challenges are satisfactorily addressed as we move from the planning stage to the operation phase?
Yeah, that's definitely a challenge, mainly because when we are planning the system and when we are granting the connectivity, at that stage, the data is not available with us. That's even not available with RE developers, what they claim. So the challenge with us remains that at the planning stage, how we can do those kind of studies, because the data is at all is not available. So yes, that's a concern for us, but how we do it when we are planning a fact device, say STATCOM, what we have planned in Fatehgarh to Bhadla 2, at that moment of time, whatever data we had with us for the RE generation, because some of the generation had come up by that time. So we emulated those generators along with replicating those generators additionally, which are going to come up in the system. And then we did that study along with that TSP, who was awarded STATCOM, especially Siemens. So Siemens was given that task to do the control interaction because at that time we had some amount of data. So at the planning stage, yes, we have constraints, why we can't do it. But yes, at later stages when the data is available as and the next phase of device comes up, especially fax devices, we do it along with the TSPs like Siemens, what we did. So mitigating measure, of course, it depends on the control strategy, how they plan it. So in China also, I was speaking to my colleagues in China. They have quite a lot more than us, definitely 600 gigawatts of RE. So they are also facing this kind of issue what we had faced. They called it dislocation compensation. So what happens over there? They are installing SVGs at the individual RE plants along with their as the grid element. So at there also the control strategy they had to define. Otherwise, they were getting the reverse behavior or the undesirable behavior of the SVG. So when the voltage was going down, it started injecting and other way around. So it's not a unique thing. It's only good thing is that Grid India is going to publish these studies, so everybody will come to know. I believe that if other countries like Germany or China, they would have given us this experience, we would have not faced this kind of challenges in operations. But definitely for the control strategies, we need to work with individual developers who are much equipped to handle those things at their equipment installation stage.
Thank you. Thank you. So you have raised one very important point regarding availability of data and also regarding coordination with the industry regarding. So from there, we are privileged that we have two of our eminent panelists who are representing the solar and the wind association. So I'd like to just seek their opinion on the kind of role that the industry association, both solar and wind, can play in one, improving the awareness of the reliability concerns that are being experienced and that have been documented in this report, and how could industry association facilitate in improving the coordination between the planners and the operators. That would, I'm sure, would go a long way in creating a common goal and also implementing what is exactly desired to implement the things. So first, we can listen to Mr. Mukund on his view on this regard.
Yeah, good evening. So first of all, I would like to congratulate Grid India for the wonderful insight of the reports, where they have clearly came out what are the issues. So at least now we are knowing what are the issues in the Indian grid where the RE penetration is more. So now moving further. So further is what? One thing is that this report is clearly saying, indicating there has to be rewriting of the inverter specification. So whatever inverter as of now is coming to the India, it has to be, specification has to be rewritten. And during the process itself, we have to demand certain data and we have to ask for the results, which is as of now is not very known to even the RE developers also, and it is not, we are all in the learning phase. So that is one of the things where as a RE developer we have to do. And for that, one of the important points which has to be done is that the writing of the construction regulation for the RE plants. As of now, there is no construction regulation for RE plant. And once this is being written, everything will come out and then ultimately it will go to the specification. And then definitely the data will come and will go to the CTU during the study. So this is what is our plan. And this is what our request to the senior leadership team of the Grid India is.
Thank you. Dr. Arul, would you like to comment?
And especially that side is of the video and
Dr. Arul Kumar. I think there is some issue. Okay, so Mr. Mukund, you have emphasized on the need for.
I got it. Yes, sir. Is it okay?
Oh yes, yes, Dr. Arul. Can we have your views on
Yes,
the ways in which? The way in which association can help us in improving the coordination.
Yeah, I heard you. I heard you.
Yeah.
I heard you. I was not able to mute. That was my struggle. Okay, anyway, he's unmuted, I think. See, I think things I know. I listened to the presentations also earlier, right? For example, I think there were a lot of suggestions, but practically today, the inverters we have in the market are where they are. And also the wind turbines further requirements beyond reactive power, and they have limited capability. So while we can work with the manufacturers, I think with the manufacturers to can't happen overnight. You know, there is a time frame in which those capabilities can be incorporated in the available for us to that extent. Association can help, but there is a time frame for doing this because these are highly specialized equipment with specific designs and a lot of other requirements beyond the reactive power and the grid compliance, right? So I think that's something I think people have to be sensitive about, and we need to appreciate it. And then as an association, definitely we can look at how to, right? See, one of the challenges with the is today, I think, see, for example, in the wind, right, for us to handle the reactive power at our point of injection is a lot easier than to handle at the grid level where we are connecting at the substation, right? So we believe that should be really in the scope of the CTU to handle that. I think we can definitely handle what is coming at the turbine level, but I think the modeling the entire system and doing the detailed studies and understanding, I think that there's a lot of cross links. In fact, today I'm in Pavagada, which is, as you know, one of the largest concentrated solar parks. But of course, we have not had this kind of issues in the south as much as we have had in Rajasthan. Of course, the requirements are slightly different, I would say, because the concentration is much higher in Rajasthan, but Pavagadh we've not had this kind of issue. So from association standpoint, I think we have already represented from multiple times CEA, various land regulations, some of the limitations, the regulations, temperature issue in both wind and solar, not of the equipment. They seem a bit arbitrary. We represent to make the corrections. We highlighted the fact that we are not able to, we are not the best in terms of modeling the power requirements because we can definitely handle it at our equipment level, but at the substation level and the PSS level, the CTU is better positioned, and certainly the emphasis on the wind power user should be to for the solar is to be focused on at our level and not so much on the CTU, right? That is best done by CTU. I think so. We have highlighted some of these points from the association members to CEA. We've not had a closure while there has been a lot of conversation on it. We've not had the rule reflects the changes. So that association can play. Association certainly can play in terms of defining with the OEM manufacturers, whether it's manufacturer, to address the requirements, develop a roadmap that's consistent with the growth, right? But certainly one thing association cannot do so ongoing. I think as a country we are quite behind on capacity addition. I think we say that we will not know how to manage the grid. The as a possibility, we're not even thinking like that. So we have to all trust in trying to increase the penetration and see upgrade the grid. The grid can be stable, right? The other area where there's is certainly
Dr. Arul, Dr. Arul, may I request, may I suggest that you can may I suggest that you can switch off your video for better quality.
Yeah, okay.
You switch off your video so that the audio is clear.
Yeah, I switched it off. Is it okay?
Yes, yes, better.
Is it okay now?
Yes, better now. Please go ahead.
Fine. So, yeah, so what I'm saying is, so I think from the cost of narrating the points is quite challenging. I think it's not at least from a VPA standpoint, we representing all these requirements for the welcome, but it done in a way so that it is not the pocketbooks of the developers, and I think it should be considered. I think that is something we need support from the authorities. We issue these changes in requirements as amendments rather than a clarification of policy, right? The another area I think we talked about the forecasting, right? The large cloud covers and stuff like that. I think this is something which is not necessarily the control developer. I think dependent on the prediction of the weather, accurate prediction of the weather, and again there are heavy penalties now with the changed DSM rules that have been put in place on the developers. But I think as a country and as an industry, I think we need to work to see how best to improve on the forecasting capabilities on the weather so that there is a predictability in the forecasting and also in the grid planning. I think this is also going to be one critical aspect to assure grid stability of the hardware and equipment changes suggested. Yeah. Is it okay?
Yeah, thank you, Dr. Arul. I could get a significant part of what you were suggesting. One thing that you suggested was that at the equipment level, you'd be taking up the studies and all that. You'll, as an industry, you would like to emphasize more, but then you suggested that some greater role needs to be played at the CTO level. But the challenge here, as we all know, is the validated models. Getting the data, the right validated models is the biggest challenge. I believe CTU is certainly capable and they are willing, and even at grid controller level also, we are quite capable of handling those. But the challenge is the data. So we were looking forward to the ways in which, as an association, you could help us out in creating a library or creating an institutional framework or helping capacity building in this respect, because many times we get applications for processing, and then there are several queries that are raised, and we find that there is some lack of capability in terms of really understanding what the requirement is and then getting it done through the agencies who are creating those models. So how can we look forward to the association support for creating that infrastructure and that ecosystem wherein the models are validated and the right data is available to the planners as well as the operators. Only then that thing can be sustainable. So, any comments, Mr. Mukund, on that?
No, I heard you say, if I can correct, I think Mukund can add also. I think he is more technical than I am. Is that, see, look, in terms of the wind or solar, right, these equipment are fairly well defined equipment. So one is a good mechanical equipment, another is an electrical equipment, right? And it's the power curves in the wind turbine are well defined. And the solar conversion from light is also very well defined, right? The challenge where I think the challenge we have, I would say maybe is on the inverter and how the inverter to the disturbance in the load. I think that may be something, while it's a electromechanical device whose characteristics should be fairly well known to the inverter manufacturer. I think maybe that is not captured well. I think that's something, a point well taken. That's something we can take it up with the WTG guys and the inverter guys, right? But the other uncertainty, the bigger uncertainty that comes from a generation standpoint, it's not the equipment per se, but it is the weather. That's what I was saying earlier. We also global a lot of locusting and routing and from IANA perspective, but we as the industry also we will try, but I think it's a bigger and just me energy, not the equipment. Maybe yes, there are some gaps in the how the inverter reacts. I think that understanding gaps may be there, which certainly as an industry we should strive to improve. But I think the biggest unknown here is the weather, which is causing much of the fluctuation, right? And I think that is something beyond the specific industries, right? That's something that has to be taken. I'm sure this was brought up with the CEA also, and also in the ministry meetings. But I think this is something that needs to be substantially improved as a country. How do we better do local weather forecasting so that we can have better planning from a grid perspective, and we have a better understanding of the weather and energy.
That part is certainly well recognized, and I'm sure you'd be aware that CA has constituted a committee wherein we have the IMD and other weather forecasters, and they are now very keen to take up this challenge and help us out in creating better models for forecasting weather, and those models that would be customized to the meteorological situations in India. So that part is well understood. Anyway, Mr. Mukund wanted to add something.
Yeah. Coming to the point on the data. So I will tell you my experience. When we have done the first system study in 2019, in this 19 the question has been effective in August 2019, and now today the 2023. So in the PSFE and PSCAT model, so we have matured enough itself to what we were getting in 2019 and what we were getting now in 2023. Now, on the perspective of the CTU and Grid India, when they study the whatever the model we give to them, some of the inverter model they give in, I will give you just bit 64. Some of the PPC will give bit 32. So what we are doing as an industry or as a developer, we are defining and we are writing the specifications not only for the inverter, but on the model perspective also, what the PSSE model should consist, what all it should consist, and in what way it should be. Similarly, the PSCAT model, what it has to be, in what way it has to be submitted. If we will able to standardize those, I believe the study part at our level, this developer level also will be very easy, and the data consistency will also be available with the Grid India and the CTU when they are reviewing any model which is being submitted. So this is one of the aspects which we are working on, not only the inverter specification, but writing for the PSSE and PSCAT with what data has to be there. So this is one step we are going ahead as a developer. And that is, I believe, that solves the CTU and all the other problems.
Yeah, thank you. That is wonderful if we can achieve that. An additional challenge that has been highlighted is the regarding getting post-disturbance data for analysis. And the report has emphasized that most of the analysis could be done only because some PMUs were available, and that resolution is also only millisecond. So is there any effort being made in at the equipment level, whether such kind of facilities are available to record disturbance data, and how can we gather that information to improve our understanding of the behavior?
Yeah, as of now, at the inverter level, there is no DFR is there. And we have seen the report also where the Grid India has indicated that the data or SOE has to be given at 1 millisecond inverter. So that is yes, as of now, I can take it as a wish list. And whatever the discussion we had with the inverter manufacturers, so as of now, they are showing their inability to give the data in this 1 millisecond resolution. But seeing the requirement of the Grid India and stability of the grid, we are having a series of meetings with the inverter OEMs, and we are forcing them, or we are giving them the requirement. This is what is required for the root cause analysis of any tripping, and so that the further improvement is there. So as of now, yes, we are doing our effort, whatever the input we have received from the Grid India, and we are hopeful, maybe not 1 millisecond, something best will come out, and that we request we will have one joint meeting, not only with the developer, with the OEM and Grid India, to come out a win-win situation solution where Grid India could also get the data where they can do easily the RCA for any event, and the OEM could also be able to give those hardware changes and software changes very easy.
Yes, certainly. I think. Yeah.
One more comment on that. We also expect association to at least sensitize all the developers to submit the data well in advance. In most of the cases, we have almost in 95%, we used to see that it is coming 2 months ahead of the commissioning. Then it becomes very challenging for both of us, for Grid India as well as CTU, to give them the requirement, because then it becomes a reiterative process to give them the comment, then they again respond to it, we find something else, and then it again impacts the commissioning of the plant. We also don't want that to happen. So the regulation, the GNA regulation definitely defines it to be 1 year, but we understand the issues of developers that their design levels is not finalized. So at least 6 months or 5 months ahead of time, they need to submit, so that last moment surprises, as Purva sir also mentioned, should not be coming to the project, and you get enough lead time to install anything if that is missing, or if not, that's a bare best case. So only request is to give the data well in advance, to have last moment rush or the problems at the stage of commissioning.
Yeah, certainly that's a very valid point. So now let me, we are privileged that we have a representative from the Central Electricity Authority, Mr. Hemant Jain. He has been quite involved in the past in building up these standards, and also he has been associated with various committees. So sir, the question that is before you, sir, is CA looking at, I'm sure there must, CA is live to the situation, and several representations are also coming before CA. So sir, what is the view of CA? Do you think that there are certain aspects of these standards which could be strengthened to improve the situation, or also in terms of the new equipments that are envisaged to be integrated in the grid, like the electrolyzers or the BESS, the provisions related to those, presently we find they are lacking. So I'm sure there must be something being thought about it and done at the CA level. If you could, sir, share those initiatives, it would be very kind of you.
Thanks, Vivek, for inviting me for this discussion. And first of all, thanks to Narasimhan Saab and Sameer Saxena ji and Ajay Porwal ji for at least making me a part of this panel discussion. And it has been a great insight for me. And congrats to Grid Controller of India for bringing out that report. In fact, that was the report which we have been discussing this issue with Grid Controller, but bringing out this report in this manner, I think it has given so much of an insight, and it has sensitized the developers also. I think that Mukund Kumarji and Dr. Arul would agree that they have given a lot of information, and I would like to stress on 2-3 points. One thing which Kashishji also mentioned and Purvalji also mentioned is that the timeline in which the data is given to CTU and Grid Controller for the first time charging and for the connectivity. I think that time frame has to be looked into by all the developers. That is my earnest request from CA side also, because what happens is at times we have been gabbling with this issue for last at least 3 to 4 years, wherein the developers say that our plant is ready, but we have not been given the FTC clearance by Grid Controller, or we are not being allowed to commission. Then actually it becomes a little sore issue, because they also need time. I think everybody would appreciate that for the studies which are required to be done, they also need their time, and they also need the requisite data. So one thing important is that the model validated data which has to be given, that has to be close to the operational condition. Let us not take it in a routine manner. It is basically, see, on both sides, as a developer or from the CTU or grid control perspective, I would say we are all technical people. So, and we are all sensitized to the issue. As Mukund Kumarji has rightly said, that it is 4 years down the line when the last amendment to the grid connectivity regulations came. So I think now everybody has matured enough, and let us sit together and join our hands so that it's a win-win situation where the grid controller does not have operational surprises as we have seen in the report. And at the same time, we don't want the developers also to suffer that the plant is ready for commissioning and we say that will take some more time or you need to take some more steps. I think that timeline is very, very important. And on the aspect of about the amendment of the regulations, yes, Vivekji, we are very much on the job, and we look forward to all suggestions from the industry, from the associations, developers, as well as we are always having our strong partnership with CTU as well as Grid Controller of India, so that we put in frame regulations which are well understood, which do not have any ambiguity, so that it becomes a legal battle at some stage. That we certainly want to avoid it's in the national interest, I would say. So let us, I would request everybody that whenever we come with the amendment of these regulations, I would solicit suggestions of everybody and we will have discussions. It's always an open discussion. And it is not that what we have stated is correct. We want to make it something which is mutually correct and which is applicable for the Indian context. And I think we all are aware that we are going to move from a regime where right now we have got non-fossil fuel capacity of 43.8% of our total installed, and we plan to move it to around 64% by 29-30. So that's a big challenge for all of us. And I think it is the right time where everybody has emphasized, and it is the right time when we should be amending our regulations to make it conducive for the industry as well as our system operators and system planners to see that the entire system is well in place and we are able to achieve the target which has been set before us. Thank you, Vivek.
Thank you for those comments. Any quick remark by any of the panel members before we close?
So last few comments.
I think thanks very much for the feedback. Sorry, go ahead, Kashish.
Yeah, last few comments on the, as Nasim sir also told, we are already on the learning curve, and I'm very happy to announce that some of the learning are already implemented in the forthcoming plants and in the already connected plants. The protection coordination already mentioned by Priyam and Rahul, and apart from that, the new TS for STATCOM which are coming, those are already being set for the new parameters of LIT compliances for 1.15 PU, which were earlier 0.3 PU. So in the Khavda STATCOMs and in future Rajasthan, we are already taking up for modification of those TS. So definitely whatever has been experienced, we are trying to be more vigilant on that and trying to build up in such a manner for the new system so that it can very well accommodate the new requirements. Regarding the switching of the steady state elements like line reactors, we are exploring the options of VSRs. We used to call it CSRs. Now it is variable shunt reactors. So it won't have the jerk effect of 125, say 240 to 0, but it definitely will be acting steps of OLTC control mode. So we'll have say 5 steps or so. So the jerk will be lesser, and the switching phenomena and the detrimental effect on the grid will be much more lesser. And I would also request Hemanji to introduce more such kind of requirements because the standards are still to define on the steady state phenomena requirements on the switching elements. That is not covered. LVRT, HVRT, yes, it is covered, but definitely RE plants complying to the requirement in steady state phenomena is another thing which we need to bring on. With this.
Thank you. Yes, Dr. Arul. Any quick comments?
Yeah, hi. Thank you. Thanks for the feedback and the working on the amendment part and all the other things. You see, in terms of the submissions, yeah, I agree. I think we are always doing it a bit last minute, and that is certainly impacting the approvals. But one thought I wanted to consider CTU and CA to consider is, look, month, for example, we had a Gadag wind plant. We lost almost a month of generation in the approval process, right? So, see, I think, of course, there has to be some in the grid, right? And certainly, we don't want to be connected with is going to make the grid unstable, right? And having said at least some improvements that we are currently considering, if there is a way, there's a minimum requirement at which a plant the grid while the developer commits to address the remaining issues in a. I think we should definitely consider that way so that we don't lose a lot of energy, especially in the current environment where the power is in shortfall. I think we can work this whole connectivity approval towards minimum, absolute minimum required for what is something we must have to make the grid robust. So we need to make that distinction to delay these connectivity approvals and waste energy, which the country very much requires now.
Thank you, Dr. Arul. I think the grid has done this wonderful job of bringing us all together. And yes, Mr.